This is the final video for 8.4, and we're going to talk a little bit more about dividing, and I also want to explain why we rationalize. So the reason why we rationalize is, let's say we take the number 1 over square root of 2. Before we had calculators, or if you're trying to do this by long division, you would set this up as square root of 2 on the outside and then divide it into the 1. Well, we can always put 0.000 and extend that as long as we need to kind of see how many times square root of 2 goes into it. Square root of 2 is approximately 1.414, and it goes on forever because it's irrational. Well, and if we think about that, if it keeps going, I can't exactly tell how many times it would go into this number because it's forever going on and on and on. The reason why we rationalize, okay, so let's rationalize so we can see what it would look like, is because when we do that, the irrational number now is going to be underneath the division sign. So now I have 2 on the outside, and now I have the square root of 2 underneath there. So it's really 2 then going into square root of 2, which is 1.414 repeating. And although this will be forever going, at least I can start the long division process for this, and I can kind of keep going to see how this would turn out. And I would get a better approximation, where vice versa, you couldn't actually divide it in there. The last thing we're going to talk about with dividing is this idea that of a binomial in the denominator. If we look at it, it still has a square root. And again, like we talked about in the previous video, you cannot have one of those in there. So what's going to happen is we're going to need to get rid of it. But if we try to get rid of it just by multiplying by square root of 2, like we did previously, again, watch what's going to happen. I would distribute it here and here, and I would get 2 plus 5 square root of 2, which isn't a problem. But when I go to distribute it here, it does get rid of that first one. Square root of 2 times square root of 2 is 2. But when I do it to the second one, it still comes back in the denominator, and that doesn't help. So the only way to kind of get rid of a square root that's within a binomial is to use what's called the conjugate. And the conjugate is basically whatever the denominator is, but opposite symbol or opposite sign. So if we have square root of 2 minus 1, the conjugate would be square root of 2 plus 1. And I want to use that in the numerator and in the denominator. And because these are binomials, what you're going to do is you're going to FOIL it. So if I do the first, you're going to get 2. I'm going to do the outer, I'm going to get square root of 2. Do the inner, 5 square root of 2, and the outer is 5. And then I'll go ahead and do the denominator. Doing the first terms, I get 2. Outer terms, square root of 2, inner term, negative square root of 2, and then the outer terms, negative 1. And what's going to happen, and this will happen every single time, is that when you FOIL that denominator, those middle terms right there will always cross out. And you'll combine the like terms on the numerator. 2 and 5 give you 7. And then square root of 2 plus 5 square root of 2 is 6 square root of 2. All over 2 minus 1, which is 1. And there's your final answer. Go ahead, pause the video for a second and see if you can write down the correct conjugate for number 16. Hopefully you wrote the conjugate as square root of 3 minus 6 over square root of 3 minus 6. Again, what you're going to do is you're going to multiply. You won't need a FOIL because it's only one number in the numerator. So you're going to get 3 minus 6 square root of 3. And if you FOIL the denominator, you're going to get 3 plus 6 square root of 3 minus 6 square root of 3 minus 36. And again, these middle numbers should cancel out. And so you're left with 3 minus 6 square root of 3 minus 33. And hopefully what you notice real quick is 3, 6, and 33. Those are all divisible by 3. So if I factor out a 3, I get 1 minus 2 square root of 3 all over 33. So that reduces, and you get, sorry, that should be negative 33, negative 11 the denominator, and then 1 minus 2 square root of 3.